Hello everybody, good morning all of you. My name is Kumar Anuj and I welcome you to Chandra classes. As you know my friends that in this series of lectures we are discussing geography, and in today's lecture the subject matter of our discussion is solar system. In solar system we have earlier seen about the formation of the solar system, and in today's topic we'll be just looking into one of the most important aspects of the solar system, that is our sun, because sun is the driving force of the solar system. As we know, the entire energy in the solar system is coming from sun, so that's why sun is the most important source, most important object of the solar system. So it is important for us to just develop our understanding about our sun, our star, and this is also relevant for our exams to have the proper understanding of our own star. So in today's lecture, under the topic solar system, we'll be looking in detail various aspects related to the sun, because sun is very important, driving force of the solar system. It is driving force of the solar system. We know that solar system originated along with the formation of the sun, our star. So that's why knowing about sun is very important. So when we talk about sun, we all know that sun, my friends, we all know that sun is a star, our star. It is having its own energy and giving us the energy as well. For example, it is the single source of energy in entire solar system. The energy in various forms, in forms of light, radiation, in various forms in entire solar system is coming from the sun. So we all know it that this is our star of the solar system. When we just think about sun, the first thing that comes in our mind, that is about its formation. Though we have seen about the formation of the sun and the entire solar system in various hypotheses and theories in our earlier lectures, but here in this today's lecture we'll be seeing about kind of a simple process, that how the sun was got formed. So about formation of the sun. Formation. When we talk about the formation of the sun, we all know that the sun was formed out of a cloud of gases and dust, a cloud, and that cloud was a molecular cloud, giant cloud. Of course, it was a giant cloud, huge cloud, giant molecular cloud. It was a giant molecular cloud, primarily of hydrogen and helium. But since there is a term here, molecular cloud, since the cloud was cold, the cloud was not in the temperature as we are seeing the sun in today's time. So cloud was cold. So that's why it was a freezing cold. It was in the freezing cold state. बहुत ही ठंडा था cloud. Since it was cold, so hydrogen was not existing in the atomic form. वो hydrogen को atom के रूप में यहाँ पर इस cloud में नहीं थी. It was in the molecular form, meaning pairs of hydrogen. So hydrogen was there in these molecular clouds, but in pairs, in the molecular form. So that's why we call this primitive cloud from which our sun is formed, we call it molecular cloud, because it was cold. Earlier it was cold. It was humongous in size. Because compressive forces of gravity were not that much dominant up to that state. So it was not observing that much compressive forces. So there was no tremendous density, and there was no temperature like that. So in earlier state, when this giant cloud was in molecular state, the hydrogen was paired. Hydrogen atoms were paired in the molecular cloud. So they were just present in the molecular form, not in separate kind of atomic form. So this was about the cloud. That was the kind of seed, that was kind of the pre-matter from which our sun, out of which our sun is formed. So this is giant molecular cloud of hydrogen and helium and some other trace amounts of some heavy elements, but those are negligible, below 1%. So 98 plus percent, more than 98%, this giant molecular cloud was made out of hydrogen, paired hydrogen and helium. So that's why we call it molecular cloud. Now, this cloud, this molecular cloud, as much as time passed, it just started getting compressed under gravity, because when we know when there is matter, the gravity is there. So because of the matter present in this molecular cloud in form of hydrogen and helium, it started it started having tremendous gravity, and under gravity this cloud started getting collapsed, because when gravity is pulling the matter, so it is kind of it is just compressing together, it's just collapsing. So because of gravity, in course of time, this molecular cloud collapsed under gravity, in what? In the form of protostar. This is important aspect here. Protostar is a pre-form of star before the nuclear fusion starts in any particular star. So protostar, now this protostar is extremely dense and having extreme temperatures. Now this protostar is not like this molecular cloud, because this molecular cloud was cold, but this protostar is extremely dense and extremely hot as well because of the compressive forces, because this cloud compressed under its gravity, and then gradually in course of time it turned out to be a protostar. In protostar, since the density is high, the temperature is high, so now suitable conditions are reaching for this protostar to turn out to be a full star. अब चूंकि सारी जो कंडीशंस हैं वो मेट होने लग रही धीरे धीरे, क्योंकि जब कोई भी प्रोटोस्टार या कोई भी जायंट क्लाउड जो है वो स्टार में चेंज हो रहा होता है, तो उसके लिए हमें क्या ट्रेमेंडस डेंसिटी चाहिए होती है, स्पेशली इन द कोर रीजन, और ट्रेमेंडस टेम्परेचर चाहिए होता है, so that the nuclear fusion could start. Once the nuclear fusion starts, that particular protostar or the object that turns out to be the regular star or the sun. We are talking about sun here. So now this protostar was reaching to that kind of density and temperature. So especially at the core region. And when we talk about this protostar, we have seen that in giant molecular cloud, the matter was present in the form of molecules of hydrogen and helium. But here in the protostar, says the temperature is extremely high. Temperature has risen up since the density has just increased. So now the matter just changed here in the form of plasma state. The matter changed here in the form of plasma meaning when under tremendous density and tremendous temperature, the electrons of the atom, they leave the orbit of the atom and they get separated. They start having their separate existence. For example, this is the nucleus of the hydrogen atom having one proton, and there is one electron in the orbit. Under tremendous pressure along with the temperature, because there is huge temperature now in millions of degrees Celsius. these electrons, they just come out of the attractive forces of the nucleus and they are getting expelled. They start having their separate existence, electrons, and proton, meaning the nucleus, especially if we talk about hydrogen atom. So we know that in hydrogen atom, the nucleus of the hydrogen atom, there is only one proton. So this proton gets separated, or you can say nucleus, you can say one proton, because both of the things are same here if we talk about the atom of the hydrogen, protium. So one proton, meaning this proton gets separated, proton with positive charge and electron, they start having separate existences. So that state of matter is known as plasma state. Now if we will talk about the hydrogen, so we will say that hydrogen is in the plasma state, meaning electrons have left the orbits. Electrons are now having their separate existence and protons are having separate existence. So the matter is said to be in the state of plasma. So similarly here, when we talk about protostar, the matter changed into plasma state. The hydrogen changed into plasma state, helium also changed into plasma state. And for the nuclear fusion to start, the plasma state of hydrogen is prerequisite. It is important. ये होना ही चाहिए. Only then the nuclear fusion can kick in, can start. So now the matter was in the plasma state, density was high, temperature was extremely high. So now the conditions were reaching for the protostar to change into the regular star. Along with the start of the nuclear fusion. Nuclear fusion starts once the temperature of the core of the protostar reaches around 10 million degrees Celsius. Around at that temperature, the nuclear fusion starts, meaning the nuclei of hydrogen or the protons of hydrogen, as we have seen, that now the matter is in the plasma state. So the hydrogen is not in the atomic form. Hydrogen protons are separate, or we can say nuclei. If we say nucleus, when we say nucleus is singular, meaning single nucleus, and plural is nuclei. Nuclei means various nucleuses, the nucleus of various atoms. So nuclei is plural. So when we talk about nuclei of hydrogen, we are talking about protons of hydrogen, because there is only one proton in the nucleus of hydrogen. There is no any neutron, nothing else. So since there is one proton, so that's why we can say protons of the hydrogen, or we can say nuclei of the hydrogen, because in nuclei itself, in each nucleus of the hydrogen, there is only one proton. So nuclear fusion, because of the optimum temperature reached here in the protostar, that was around 10 million degrees Celsius. Since the optimum temperature reached, the hydrogen, the nuclei or the protons of hydrogen, they started going through the process of fusion, and nuclear fusion started. Under nuclear fusion, the protons of hydrogen, they change into helium. Under a process, there is entire process involved in this fusion, but if we just largely talk about, then protons or nuclei of hydrogen, they fuse together to form helium, and that's why the hydrogen, that is the fuel of the nuclear fusion, starts getting ended up, starts getting used up, and helium is getting formed continuously. So once the nuclear fusion starts, the hydrogen will constantly get on reduced, and helium will just keep on increasing in the particular region, meaning the core region of the protostar or the core region of the star now, because nuclear fusion has started. So these protons of hydrogen, they change into helium, and energy is released. Energy in form of gamma rays. Tremendous energy is released in the form of gamma rays. Those gamma rays, then they ultimately they just strike through the radiative zone, then they get weakened. Then after we get ultimately the heat, the light that we are getting from the sun. So this is a kind of overall process that takes place that gave birth to the sun, and the nuclear fusion started, and energy started getting generated in the sun, and it is the energy that what we are getting on the earth as well right now, because this is the process which is going in the sun, that is nuclear fusion. That's why we are getting all the energy from the sun. So that's how the formation of the sun took place from a giant molecular cloud. When there was the giant molecular cloud, then the hydrogen was present in the molecular form, pairs of hydrogen. Gradually it turned out to be in the atomic form, hydrogen atoms. Then after it turned in the plasma state. Then further the temperature was just gone up. Then hydrogen turned in the plasma state. In plasma state, protons, meaning the nucleus, it gets separated from the electrons. Electrons start having their separate existence. Electrons अपना अलग हो जाते हैं न्यूक्लियस से, तो वो प्लाज्मा स्टेट बन जाता है मैटर का. तो यहाँ पर ये प्लाज्मा स्टेट बन गया. प्लाज्मा स्टेट इज प्री रिक्विजिट फॉर द न्यूक्लियर फ्यूजन टू स्टार्ट. So that's why. And plasma state of matter turns under tremendous density and temperature. जब टेम्परेचर इतना अधिक हो जाता है कि इलेक्ट्रॉन्स जो है ये इस प्रोटॉन के जो अट्रैक्टिव फोर्स होते हैं जिससे प्रोटॉन इलेक्ट्रॉन को ऑर्बिट में बाइंड करके रखता है, वो उससे ओवरकम कर जाते हैं और वो दे स्टार्ट हैविंग सेपरेट एग्जिस्टेंस. इलेक्ट्रॉन्स स्टार्ट हैविंग सेपरेट एग्जिस्टेंस. So that is plasma state of matter. And in plasma state of matter, then protons, or we can say nuclei of hydrogen, they fuse together to form helium. Then they fuse together to form helium. And in this process, tremendous energy is released in the form of gamma rays. And finally we get the heat, the light from the sun. So that is the entire process. Now just we have seen about the formation of the sun. Okay, so that was the formation. But when we talk about another aspect associated with the sun, that is structure of the sun. Structure of the sun. Now if the sun is formed, the star is formed. Now we will just look the structure of the particular star, because we know that there are various layers in the atmosphere of the sun, various layers within the sun, for example core, radiative zone, convective zone, etc. So we will be looking the entire framework, I mean structuring of the sun, our star. So when we talk about the structure of the sun, so first of all we see there is the core region of the sun. Core. The temperature of the core of the sun, is around 15 million degrees Celsius. 15 million degrees Celsius. That is the temperature of the core of the sun. Because the temperature of the core of the sun is so huge, that's why That's why the nuclear fusion is taking place in the core of the sun. हमें पता है कि जब भी न्यूक्लियर फ्यूजन स्टार्ट होना होगा तो वहां पर फ्यूल होना चाहिए, हाइड्रोजन होनी चाहिए इन प्लाज्मा स्टेट, और वहां का टेम्परेचर और डेंसिटी एक्सट्रीम्स होने चाहिए, एट एक्सट्रीम. सो टेम्परेचर वहां का एटलीस्ट नियर अबाउट 10 मिलियन डिग्री सेल्सियस होना चाहिए, तभी न्यूक्लियर फ्यूजन कैन स्टार्ट. So that's why at the time of the start of the nuclear fusion in the core of the sun, the temperature was around 10 million degrees Celsius. That's why the nuclear fusion could start. But once the nuclear fusion starts, the energy is getting generated exponentially and further temperature increases. That's why we see the temperature of the core of the sun now is around 15 million degrees Celsius. And this core is the region where the nuclear fusion is taking place. The nuclear fusion only takes place at the core of the sun because of the optimal requirements, density, tremendous temperature. So optimum kind of conditions are there only at the core of the sun. That's why nuclear fusion takes place only at the core of the sun and no at no any other place in the sun. So the nuclear fusion, this is the site of the nuclear fusion, that is core, site of the nuclear fusion. Then after we have radiative zone. Then after we have radiative zone. Then after we have convective zone. Then after we have convective zone. And this convective zone just merges with the photosphere because this is the outer visible layer of the sun. This is the outer visible layer of the sun. And after photosphere, we have chromosphere. We have chromosphere. After photosphere, sorry for that. After photosphere, we have chromosphere, meaning atmosphere of sun, the layer of the atmosphere of the sun. And after chromosphere, we have corona, the outermost layer of the sun. Just we'll look into detail. So first of all, we know that core of the sun is the site where nuclear fusion takes place. यही वो site है जहां पर nuclear fusion हो रहा है. And that's why we see the temperature, humongous temperature, 15 million degrees Celsius. Sorry. Now, since the nuclear fusion is taking place and energy is getting generated, especially in the form of gamma radiation. So, the energy is transported, the energy from the core is transported outwards in the radiative zone, in form of gamma radiation, because energy is produced here especially in the form of gamma radiation, and then gamma radiation radiates to the nearby region, and that's why this region is known as radiative zone, because here energy is transported in the form of gamma radiation. Further, when we talk about the transportation of energy from radiative zone to the convective zone, this is convective zone. This is convective zone. This is convective zone. In convective zone, the convection of plasma takes place. In the convective zone, energy is getting transported in the form of convection of plasma, as we see the convection currents in our interiors of Earth. We see convection currents in the outer core region. We see convection currents in the interior of Earth, in asthenosphere. We know the various phenomena with respect to plate tectonics. They happen because of the convective currents taking place in the asthenosphere, the layer in the Earth. So similarly, the convection takes place here in the convective zone, and energy is transported through the convection of plasma. Convection of plasma. Convection of plasma. So in convection, for example, if you are boiling the water in a particular bowl or pot, so you see that the hot water is just comes up in the process of convection, and the cold water settles down. And when that cold water that comes in the contact of heat and again gets heated up and again comes up, and comparatively cold water on the surface sinks down. So this is kind of convection that takes place here. Similar convection is taking place in the convective zone. Matter is plasma. Matter is plasma, because constantly the plasma which is in touch with the radiative zone becomes extremely hot. Then it pops up, and comparatively cooler plasma towards the outer surface of the convective zone, it sinks down. And similarly, the heat is getting transferred to the next layers. So that's why we call it convective zone. After convective zone, this is the yellow looking line, the outermost yellow looking line is photosphere. This is very important. Photosphere. This is very important sphere of the sun. Photosphere. When we talk about photosphere, so photosphere is the visible surface of the sun that we see. जो हमें दिखाई पड़ रहा होता है, जब हम सन देखते हैं, जो हमें दिखाई पड़ रहा होता है, जो आउटर सरफेस जो हमें सन की दिखाई पड़ रही होती है, दैट सरफेस ऑफ द सन इज फोटोस्फीयर. हमें ये रेडिएटिव जोन, कन्वेक्टिव जोन, ये जोन दिखाई नहीं पड़ते हैं, ये बिकॉज दे आर विद इन, बट द आउटर मोस्ट विजिबल लेयर, that is photosphere, because all those layers, all the other layers like chromosphere, corona, all the other layers are the part of the atmosphere of the sun. Like we are also having atmosphere on the earth in form of various layers like mesosphere, stratosphere, troposphere. Similarly, these layers, chromosphere, corona, they are the part of the atmosphere of the sun. But here this is the entire region that belongs to the main body of the sun, and this is the outermost surface that is known as photosphere. So photosphere, when we talk about photosphere, photosphere is the outermost surface, that is visible surface. It is called, why it is called photosphere? Because photo, when we say photo, so photo means light meaning visible light. Since this layer is the visible part of the sun that we see, the outermost layer, that's why the astronomers, the observers called it photosphere. इसीलिए उन्होंने उसको photosphere बुला दिया, क्योंकि ये हमें दिखाई पड़ती है, जो सन की outermost layer है, covering है, ये हमें दिखाई पड़ती है. That's why it was named as photosphere. इसीलिए इसको photosphere नाम दिया गया. Sorry. This photosphere, the temperature of this photosphere is around 5500 degrees Celsius. 5500 to 6000 degrees Celsius around. This temperature, we can just compare this temperature with the core of the earth, our earth. We know that the temperature of the inner core of the earth is also around 5500 degrees Celsius. So we can compare this temperature of the photosphere of the sun with the inner core of our earth. So this is about the temperature of the photosphere. Now this is the source of visible light. This photosphere is the source of visible light. Visible light in the solar system. So since we see that a photo equates to the light, and this photosphere is the visible outermost surface of the sun, so it is the source of visible light in the solar system. Nothing to be bothered about that. It's easy. And temperature 5500 degrees Celsius. So these are some basic aspects related to the photosphere, the surface, that is the outermost visible surface of the sun. Now, if when we just come to the atmosphere of the sun, then the layer which is above the photosphere, that is known as chromosphere. 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 When we were just coming outwards from the core region of the sun, the temperature was constantly decreasing because the temperature at the core was 15 million degrees Celsius. Then it reduced to few million degrees Celsius in the radiative zone. Then again it reduced to few thousand degrees Celsius in the convective zone. Then in the photosphere we see the temperature is around 5500 degrees Celsius. But again it starts rising when we just sail through the atmosphere of the sun, when we just approach towards the atmosphere of the sun. So when we come to the chromosphere, the temperature again rises. And this chromosphere, why this is called chromosphere? Now this is also important fact. Chromo, when we say chromo, so chromo implies color, meaning something colorful, not exactly black and white. So when there is any kind of solar eclipse happens, so during solar eclipse, the outer kind of disk type of layer that we see around the outer layer of the sun during solar eclipse, so it looks reddish in color. And that's why the observers called it chromosphere, because it was looking reddish during the eclipses. So that's why observers called it the chromosphere, because it was having some color. So that's why we know it as a chromosphere layer. Then after the last outermost layer, that is known as corona. The outermost layer, that is known as corona. Now, how this was named? Corona is a Latin word which means that crown. So this outermost layer during the total solar eclipses, this outermost layer looks as a crown of the sun, like white glowed, just crown, meaning white glow. When there is the total solar eclipse, this outermost layer of the sun, it just glows extremely white and looks like the crown of the sun. ये sun का जैसे crown हो चारों तरफ से, ये crown की तरह दिखती है. That's why the observers named it corona, because in Latin corona means crown. So that's why it is. Temperature further rises. In corona, it reaches around 1 to 3 million degrees Celsius. And this rise of temperature is caused due to various factors, including the magnetic field alignments of the sun, realignments of the sun. So the temperature of the corona is around 1 to 3 million degrees Celsius. So if we talk about the atmosphere of the sun, the highest temperature is found at corona. But if we talk about entire sun, or if we talk about entire solar system, the highest temperature is found at the core of the sun. This is the highest temperature in the solar system, highest natural temperature in the solar system, anywhere that exists. That is around 15 million degrees Celsius, that is at the core of the sun. But the temperature of the corona is around only 1 to 3 million degrees Celsius, which is highest in the atmosphere of the sun, meaning atmospheric layers of the sun, chromosphere, corona, etc. So this is about the outermost. This is the outermost layer, glows like crown and visible like crown during total solar eclipses. So that's why it is known as corona. It was called corona by the observers. In Latin, corona means crown. So this is about the structure of the sun, various layers of the sun, atmosphere, etc. This corona is outermost atmospheric layer of the sun. It spreads millions of kilometers into space, because this is a glow, this is halo of white light. This is especially halo of white light, halo of white light. So it spreads millions of kilometers deep in the space all around the sun and looks like crown, especially during total solar eclipses. That's why it is known as corona. So this was all about the structure of the sun, important aspects we saw about the temperature, about the sequence of layers. In exam, they can ask various types of questions from here. They can ask about the sequence of the layer. For example, if they are giving a photosphere, chromosphere, corona, then asking you to realign all these layers and then find out the suitable option. So they can ask various types of questions from here, from the structure of the sun. So that's why it is very important for us to remember the sequence of layers. From the core to the corona. So just to revise once, core, then after radiative zone, then after convective zone, then after photosphere. Photosphere is very important, that is surface of the sun. Then after we have chromosphere, then after we have corona. And then the sequence of temperature. 15 million degrees Celsius at core, reduces in the radiative zone, again reduces in the convective zone, and at the surface of the sun, that is photosphere, it reaches around 5500 degrees Celsius to 6000 degrees Celsius. So the temperature of the photosphere is also very important. This has been part of exams, various types, various questions. And then after, when we just approach from the photosphere, we transit in the atmosphere of the sun, again temperature starts rising. दोबारा टेम्परेचर बनने लग जाता है. In the chromosphere, it again reaches to many thousands of degrees Celsius. And in corona, the outermost layer of the sun, the atmosphere of the sun, we see the temperature again reaches from 1 to 3 million degrees Celsius again. So this is another important fact here to be remembered. So if they are asking the exam, for example, which is the outermost layer of the sun, they can give you various options like chromosphere, corona, photosphere, various options. Then you will have to find out that corona is the outermost layer of the atmosphere of the sun. So they can frame various types of questions from here. That's why it is important to understand the structure of the sun. In next setting, we'll be just studying about motions. The next important aspect associated with our sun, my dear friends, is motion. Motions. So this is the next important fact associated with the sun, our star. We know that our earth, it exhibits various types of motions, various types of movements like rotation, revolution, axial precession, various types of motions we'll be just studying later on when we'll just study about earth. But here we are talking about motions of our sun. Sun is not static. Sun is also under motion. Like our earth, we see that the earth is rotating on its axis. Then after, earth is also revolving around the sun. Similarly, sun is also observing, sun is also showing, sun is also exhibiting various types of motions. So we'll be looking important motions as exhibited by our star sun here. So the first important motion of the sun is rotation. It is very important. The rotation is the first important motion of the sun. But when we talk about rotation, we imagine like earth, because earth rotates on its axis and completes one rotation in around 24 hours. But this is not the case with the sun, because sun is gaseous body. It is made out of gases. It is sphere of gases. ये गैस का गोला है. So it won't orbit, it won't rotate as the earth is rotating, because earth is a kind of terrestrial planet. वो एक terrestrial solid planet है, made out of silicon, iron, etc. various components, magnesium. So earth तो एक terrestrial planet है, तो वो rotate कर रहा है, यानी together each and every latitude of the earth is rotating together. But here this says sun is a gaseous planet, क्योंकि सन जो हमारा गैस का गोला है, so that's why it observes differential rotation. Differential rotation. Now what is differential rotation? Important aspect to know. When we say about differential rotation, it means, for example, this is our sun. This is the imaginary axis the sun is rotating on. But since the sun is made out of gases, for example, this is the equator of the sun, and these are the polar regions, poles. Since sun is made out of gases से बना है, especially hydrogen and helium, so each and every latitude of the sun does not rotate together. एक साथ साथ वो नहीं घूमते. They have differences in their rotations. For example, if 0 degree, this latitude, meaning this region of the sun, equatorial region of the sun, if it completes its rotation around 25 earth days, in around 25 earth days, if the equatorial region of the sun, it completes one rotation in around 25 earth days, so the poles, they take around 35 days, 35 earth days to complete one rotation. So that's why we say that sun exhibits the differential rotation. Equator is rotating. What does it mean? It means the equatorial region of the sun, it is rotating faster than the polar regions. Because equatorial region, that completes rotation in around 25 earth days, and polar region completes rotation in around 35 earth days. Extremely important for our exams. Extremely important questions could be framed here. They can give you the sun rotates in equal amount of days at each of its latitude. They can give various types of statements. That could be the wrong statement, because sun observes differential rotation and it rotates differently, meaning different time is taken at each and every latitude, at each and every region of the latitude of the sun. So that's why if we compare the equatorial region to the polar region, we see that the difference is around of 10 days. It is huge difference. If the time is taken around only 1 month, so this is a huge difference of 10 days, around 10 days. Sorry. So this is about the differential rotation that the sun observes. The second important motion or motion of the sun is a revolution. As our earth revolves around the sun, then the sun also revolves around the center of the galaxy. Center of galaxy. And the name of our galaxy is Milky Way. So the sun is also revolving, orbiting around the center of galaxy, that is Milky Way. Because sun is the part of a Milky Way galaxy and situated in its right arm. For example, here, this is our solar system. In this Milky Way galaxy. For example, this is Milky Way galaxy, and our Milky Way galaxy, it is having two arms, and our sun is situated, meaning our solar system is situated in the right arm. राइट आर्म ऑफ आवर गैलेक्सी मिल्की वे। जो हमारी गैलेक्सी है मिल्की वे, इसकी राइट आर्म में, आर्म कोई आर्म किस चीज की बनी होती है? वेरियस स्टार्स, वेरियस सेलेस्टियल ऑब्जेक्ट्स, सो उसी की सारी आर्म्स बनी होती हैं। आर्म्स लाइक स्ट्रक्चर, सो आवर गैलेक्सी मिल्की वे इज जस्ट लाइक इन द स्ट्रक्चर ऑफ आर्म्स हैविंग टू आर्म्स। और हमारा जो सोलर सिस्टम है that is situated in the right arm of our galaxy Milky Way. So this is also important fact. So that's why I mentioned here. Now, after revolution, there is another motion. There is another motion of the sun. That is oscillation or wobble. Oscillation. When the sun is revolving around the center of the galaxy, so it is not revolving in a flat surface. It is wobbling like that, revolving and wobbling. For example, if the solar system, meaning sun, is revolving around the center of the galaxy, if my shoulders are the center of the galaxy, so sun is revolving like wobbling. It wobbles like that. So it completes one wobble, meaning one oscillation in around 70 million years, in around 70 million years, while orbiting around the center of the galaxy. So this is oscillation motion of the sun. And as we see here, that revolution of sun around the center of the galaxy, so this revolution gets completed in around 250 million years. So sun completes one revolution around the center of the galaxy in around 250 million years, and that's why this time frame, meaning the completion of one revolution of sun around the center of the galaxy, that is known as one galactic year. That is known as one galactic year. Galactic year. This is another important fact to be remembered. So this is all about the motions of the sun. Now we'll be talking about the next most important aspect is solar magnetic activities. 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 So as the name is suggesting that something is associated, with the magnetic field of the sun, magnetic field lines of the sun. As we know that there is magnetic field of the celestial objects, there is a magnetic field of our earth as well, and we are getting various advantages out of that. We'll be looking here that we are getting various advantages of the magnetic field of earth that protects us from various types of charged particles at the outermost layers of our atmosphere, at the magnetosphere. So in solar magnetic activities, there are various activities. The most important activity associated is sunspots. That is sunspots. Sunspots. What are those? Sunspots, they are comparatively darker. They are comparatively darker. They are comparatively darker, cooler regions. Where are they? Where do they remain? They remain at the photosphere. Comparatively darker, cooler regions at the photosphere. they are comparatively cooler. They are not like that we can be there. They are comparatively cooler. As we know that the temperature of the photosphere is around 5500 degrees Celsius. So the temperature at the sunspot regions, that could be around 3500 or 3000 degrees Celsius. So they are comparatively cooler. That's why they are called darker regions of the sun, darker regions of the photosphere. They remain at the photosphere. And due to the concentration of, they are caused due to concentration of magnetic field lines. Magnetic field lines. Due to concentration of magnetic field lines, we see that we have seen that the heat from the core of the sun, that is getting convected to the photosphere through the convective zone, through the convection of plasma. But since because of the concentration of magnetic field lines around the particular regions at the photosphere, the convection of plasma, meaning the convection of heat, gets on getting obstructed by the concentration of magnetic field lines. And that's why those regions become darker, cooler regions, because of obstruction of the convection, the convection of heat from the interiors of the sun. So that's why they are caused due to concentration of magnetic field lines. And this concentration happens occasionally because sun observes differential rotation. Because sun is exhibiting differential rotation, that's why the magnetic field lines of the sun, they keeps on getting twisted and tangled. And then they, after certain types of tangling, they realign themselves. And that's why these solar magnetic activities, they take place. And sunspot is one of them. Now, the next one, solar flares. Solar flares. When we talk about solar flares, so these are bursts of radiation. Bursts of radiation. Bursts of radiation. They are also caused around the sunspot regions due to the bursts of radiation, due to the reconnection, magnetic reconnection, caused due to magnetic reconnection, meaning reconnection of magnetic field lines, because sun is observing differential rotation. So that's why the magnetic field lines of the sun, they keeps on getting twisted and tangled, and then they reconnect. So during reconnection, bursts of radiation, they are getting radiated from the photosphere. Those are called solar flares. And since these are in the form of radiation, so our magnetopause, meaning the magnetopause of the earth, which stops the charged particles, cannot stop solar flares, because they are especially mostly in the form of radiation, and our outermost magnetopause does not much interact with the radiation, and that's why they get almost a free passes, and they disturb our ionosphere. They cause ionization at the ionosphere, and due to that we get radio blackouts, radio waves, radio blackouts on the earth. Satellites are getting affected, meaning communication, GPS, etc. getting affected. And since this is radiation, this can also affect the astronauts in the space. Astronauts, our satellites, they can also get affected because of these solar flares, this phenomena, solar flares, because this is exactly a kind of radiation which is coming out of the sun. The next important associated aspect is coronal mass ejection. Coronal mass ejections. And the last one would be solar wind. Solar wind. So looking one by one. Coronal mass ejections. if we talk about coronal mass ejections, as we see that the outermost layer of the atmosphere of the sun is known as corona. And due to readjustment of magnetic field lines, sometimes the mass from the corona, that's why the name is coronal mass ejection. This is mass, this is not radiation, this is mass. So certain mass getting ejected from the corona in the space, towards the space. And in that mass, what remains? That is plasma. There is plasma of hydrogen and helium. So in that mass, there are charged particles of hydrogen and helium. So this mass contains charged particles, hydrogen, helium, etc. Charged particles. And these charged particles, when they come towards Earth, for example, then the magnetosphere of the Earth, the magnetopause, the outermost layer of the atmosphere, the magnetopause of our Earth, it redirects the charged particles toward the polar regions of the Earth, because at the polar regions, the magnetic field lines of the Earth, they are just moving inwards. That's why they get chance to enter in the atmosphere of the Earth, coronal mass ejections, at the polar regions of the Earth. And then they come into contact with the matter in the atmospheric layers of the Earth, various types of, for example, oxygen, nitrogen, various gases, atoms of various gases, and then they sparkle and create a kind of sparkling light, and that light is known as aurora. Auroras at poles, aurora borealis, aurora australis. So this phenomena is called due to the redirection of these charged particles, meaning CMEs, coronal mass ejections, by the magnetic field lines, that is magnetopause of the Earth, towards the polar regions of the Earth. So this is about coronal mass ejection. So they can cause minimum damage on the Earth because of magnetopause. Our magnetopause, it protects us from the coronal mass ejections. It redirects. Similar is the case with solar wind. Solar wind is a constant release of, it is kind of a continuous flow of charged particles. Coronal mass ejection, it happens because of realignment, readjustment of magnetic field lines. It is a kind of burst, sudden movement. But if we talk about solar winds, then solar winds are continuous flow of charged particles. Continuous flow of charged particles. Same hydrogen, helium charged particles. So it is continuous flow of charged particles. This happens because of thermal energy at the sun, because we know that there is tremendous thermal energy, especially at the corona. So, and magnetic field effects. These solar winds blow out of the sun. Magnetic field lines, they open at the corona and provide a free passes to the solar wind to just blow out. So similarly, the solar winds, they keep on blowing, and these solar winds, since they are also charged particles, so if, for example, when they come towards the Earth, they try to enter the atmosphere of the Earth, then they are again obstructed and redirected by the magnetopause of the Earth. the outermost atmospheric layer of the Earth, magnetopause, it redirects the charged particles towards the polar regions and protects our Earth from these charged particles of solar winds. So that's why we see the magnetic field lines of the Earth, they protect us from the charged particles. Those are coming from the sun. They could harm us in various ways. But since magnetopause, we are having magnetopause covering the atmosphere of the Earth from all around, protects us from the charged particles that are coming from the sun in the form of solar winds or coronal mass ejections. So this is all about solar magnetic activities. We saw sunspots, solar flares, coronal mass ejections, solar winds, etc. Now, one or two important other important aspects with respect to sun is, for example, this is our sun and this is our Earth. Our Earth revolves around the sun in an elliptical orbit. So the distance between the Earth and sun is not constant. It keeps on changing. Sorry, because of the elliptical nature of the orbit on which the Earth is orbiting the sun. But if we talk about the average distance between the sun and the Earth, meaning not exactly if the Earth is here and not exactly if Earth is farthest. If we talk about average distance, meaning any middle kind of distance between the Earth and the sun, then this distance is around 150. This distance is around 150 million kilometers. 150 million kilometers. That distance is also known as 1 astronomical unit. So whenever we just measure the distance of any object in the solar system or in the outer space that is not too much at distance, we can calculate the distance in astronomical unit. For example, if we say that the Pluto, the orbit of Pluto is far away from Earth by so and so astronomical unit, because we can keep the reference, we can keep the distance between the Earth and the sun as the reference point to calculate the distances between other objects in the solar system. So this is 1 astronomical unit. They can ask in the question, what is astronomical unit? The distance between the sun and the Earth, the distance between the Mars and the sun, the distance between the Jupiter and the sun, the distance between the Earth and the Jupiter. So they can give you various options to confuse. But this is astronomical unit, that is average distance between the Earth and the sun, that is around 150 million kilometers. And the next important thing is light. For example, light also reaches to the Earth. So on an average, the light takes 8 minutes and 20 seconds to reach from the sun to the Earth. So this is the time taken by the light, average time, 8 minutes and 20 seconds. So this is another important fact to be remembered. This can be the part of question anytime in upcoming exams. So that's why this was all about our dear star sun, because we are all alive because of the sun, because sun is providing us energy and we are getting almost entire energy from sun in various forms. The energy that we get, for example, photosynthesis could not have been possible if there was no sunlight. So that's why all the processes, living processes, lively processes, they are taking place because of the energy that is being provided by the sun. And we saw various aspects related to the sun in this lecture. So this is all about in today's discussion. Now I'm just excited to meet you in next lecture tomorrow with new topic. Thank you for joining in.